Greetings, folks, and welcome to the Electromaker Podcast. Today we have another very special episode. It's with Alasdair Allan, who is the head of documentation at Raspberry Pi. Alasdair is a very interesting person. This is his third or fourth career. He started out as an astrophysicist and had various routes along the way, getting into hardware, being a journalist, and ending up as the head of documentation. As we go into in the podcast, his first big job was the RP2040 documentation around the Pi Pico, and those wonderful Raspberry Pi booklets that are about the Pi Pico, they are the result of him and his team's work. This is a somewhat more podcast-oriented interview than the Eben Upton interview was, because obviously he's the CEO, and he was very gracious with his time, but it was very clear that he had things he wanted to talk about, and talked about them in a certain way. This was much more of a sort of rambling conversation. I did ask the questions that I hoped people would find interesting, as always, and Alasdair will definitely be joining us again at some point in the future, because in an hour and 10 minutes we barely scratched the surface of the things that we wanted to talk about. This interview starts sort of, once again, like in medias res. I love that phrase, even though it's probably the wrong usage of it, because there was a few minutes at the start while I was testing out the sound, and I was explaining to him a little bit about who I am, because it was the first time we'd met. And we lead into the interview more or less just as the conversation really turns round to Alasdair. So, without any further ado, Alasdair Allan. Who aren't really familiar with it, do you want to quickly introduce who you are and what you were doing at Raspberry Pi?
So, my name is Alasdair Allan. I'm the head of documentation at Raspberry Pi, and I've actually had a pretty odd path to where I am now. I'm on my third, maybe fourth career, I think. I started off as an astrophysicist doing research into high-energy physics of collision shocks and accretion disks surrounding white dwarf stars, and then I sort of drifted sideways into playing with the toys. After spending a few years building agent-based systems to schedule a network of robotic telescopes, I became interested in and did a bunch of work around machine learning and what later became known as big data. And it was then I spent a lot of time investigating the data exhaust, the data that lives outside of the cloud in embedded and distributed devices, which is how I got interested in cell phones and microcontrollers. In fact, I got really interested in sensors and mashing them together with the then new smartphones, and I ended up writing a few books about that, including one on how to get RS-232 devices to talk to the iPhone. And it was during that period of my life I was responsible for causing a US Senate hearing. Anyway, I then spent a few years as a technology journalist, for the most part writing and talking about the maker movement and the sometimes new, sometimes recycled things that were happening there. And latterly, I did a bunch of work around the new TinyML movement and the folks attempted to cram machine learning inferencing down onto microcontrollers. And while I was doing that, I spent a lot of time talking to the folks at Raspberry Pi, which is how I ended up here today, heading up documentation there. It all sort of made sense at the time.
Yeah, that is quite the movement. I mean, I can definitely see where you came from, sort of the hardware hacking and into the journalism side of it, and then towards Raspberry Pi. But that first step from being an astrophysicist, I guess that's quite an interesting place to start, actually, because I think the kind of world that the Raspberry Pi and various other, let's say, more maker-friendly boards inhabit crosses over with so many scientific disciplines and artistic disciplines and all that kind of stuff. Was it something that you found a quite natural process, just actually getting into the hardware hacking side of it to get things to do essentially what you wanted them to do?
So my first collision with hardware was back when I was an undergraduate. These many years ago now. But back then, of course, if you wanted to blink an LED on and off, it was a week-long process if you were lucky. You got a new chip, you had to put it on a board, like the development boards were the size of the Times newspaper, and there was a manual that was 6 inches thick, and the development software came on 10 DVDs, well, CDs, I guess, back then, or mag tapes, actually, in one instance. And to get that started up, just to get into the blinking and LED, it was a process. And I remember coming across Arduino at I believe it was O'Reilly eTech, with one of the early O'Reilly conferences that sadly went over their emerging technology conference, and I was in a class with Tom Igoe, one of the co-founders of Arduino. Mm-hmm. And the fact that you could get an LED to blink within minutes and spin that up was groundbreaking. And I mean, that was the start of my slip into playing with the toys. It was I was working on trying to schedule observations across a large network of robotic telescopes. So the telescope network was scattered across the globe at the time. And one of the things that we needed to feed into that was like local weather conditions of the instrumentation. So those telescopes had to be instrumented up. They had to have lots of things measured. And doing that was expensive. It was time consuming. And being able to use the maker technologies that were just then starting to arrive to do that was a real eye-opener for me. And it really did lead to my slip into the dark side.
Yeah, I mean, it is kind of amazing, really. I suppose one of the things that is interesting to me as well is that as someone who, because I'm also sort of on, I guess, third career here, I suppose, in that I was, my father actually was a teacher of computing and programming, still is to this day, even doing long distance over the internet teaching. And he was one of those people that, like many others, had a sort of homemade attempt at a computer, a 6502 system that never quite did what he wanted to. But and he had waded through all of that documentation. I have in my bookshelf at my parents' house now just a bunch of the first edition of Turbo C documentation books and all this stuff. Of course, he was my father, so I didn't care. I didn't want anything to do with it. I was a punk. I picked up a guitar. Finally got around to getting into microcontrollers many years later. But for me, something that I did not appreciate at the time at all was how amazing it was that I could get an Arduino, and with the little programming knowledge I had at the time, that, as you say, I could make an LED blink. But not only that, I could make an LED blink using a very easy to use, even at that point, IDE, and a pretty well documented thing. And that's been pretty much my same experience with Raspberry Pi as well, because like I said, my initial journalistic jobs were writing about Raspberry Pi in a tutorial format, and of course that meant that I had to learn how to do that first. But yeah, I was going to ask this a bit later, but I think it fits quite nicely now. Embedded hardware really does have that reputation for being somewhat impenetrable. And where there is documentation, it's hard to follow. Sometimes there isn't. Where there is support, it's sometimes sporadic, and sometimes there isn't. I mean, why do you think that's still the case now with a lot of the bigger manufacturers? Are they just aiming at engineers in the industry, or do they maybe not understand the needs of maker, or maybe kind of more beginner culture?
Yeah, I mean, I think that's exactly it, really. Historically, the documentation is the last thing that people think about. But you have to take a step back. My entire philosophy around this is that humans are story-driven creatures. We consume stories about ourselves and stories we tell to others. Documentation, technical documentation, is still a story. And it has to have a narrative. And I mean, this is especially true for getting started documentation, but I think it applies to all documentation. I mean, even something as impenetrable to most people as a data sheet for a chip. And we'll talk about RP2040 and then the ASIC documentation later, I guess. But documentation is narrative. You have to have a beginning, you have to have a middle, you have to have an end, and they have to have a happy ending and go off into the sunset, right? It's a story. And most people don't understand that. Most people don't get that when you are telling people how to plug in a microcontroller and blink an LED, it has to be a story. There has to be a narrative arc leading people through it. And it sounds wishy-washy and it sounds, so arty-farty type sort of thing. But it is very, very, very much a thing that has to be done if you want good documentation, if you want documentation that's approachable, not just by experts in the field. And of course, the thing about being an expert in the field is you'll skip across all of the narrative and you'll totally ignore it. And that's fine because you can pick out like the code blocks or the instructions that you need. And very much so what people will do with important things that the experts have to pay attention to is they'll be in note blocks or important blocks or something. They'll be called out in some way. So your eyes will scan down and you'll pick up the note blocks and you'll pick up the bits that you need and you can ignore the rest. But you should think yourself privileged for that because you have a background that means that you can do that. Not everyone does. And documentation should be about accessibility. It should be about letting people that are transitioning in from different fields, that are transitioning from slightly different microcontrollers even, or slightly different programming backgrounds, that don't quite have the same background as the people that built it.
Yeah.
Get into it as easily as possible. And I mean, that's where a lot of manufacturer documentation falls down, because it is written by, and all honor to them, they write things down. Like it's hard to get engineers to write things down. They don't want to. They want to go build things. That's what they're about.
Yeah.
And that's fine. But it's like most manufacturer documentation is written under sufferance by engineers that don't want to be there, that don't want to be writing documentation. And that's one of the things that I love about working at Raspberry Pi, in fact, is that the engineers there really understand that documentation is important. And it's been extremely pleasant trying to pull the documentation together, because the only people that can write them are the engineers that build the things in a lot of cases.
Yeah.
I mean, I can write with enough scattered Post-it notes and Google documents and spreadsheets, I can pull together getting started guides for most things. But if you want to dive deep into something like ASIC documentation or the data sheets around boards or stuff like that, well, the only person that can write that documentation is the person that built the thing.
Yeah.
So getting them on board, getting the team on board to write the documentation, to build that into a narrative, is absolutely vital to good documentation. And most manufacturers, most large manufacturing companies probably don't have that. They don't have people that are passionate about building good, accessible documentation.
Yeah. I mean, it's something that I think, I mean, if you think about it, it's almost obvious really that you get people who are very good at putting things into words and describing things simply. But the Venn diagram of those people, and then people who understand the complexities of, especially kind of, as you say, application-specific things these days, is probably very slim. And the chances of having one in your, even if you did have one in your company, that you'd still only be giving them work every time you had something new to come out. So I understand why, from a personnel point of view, it's somewhat difficult. And there are companies that are trying to address that balance. I do know. I mean. In our work here at Electromaker, we had a contest recently with Nordic, and I was really surprised how many people from Nordic were happy to kind of jump into the conversation in the Discord server to just help specific problems, because they really want people to use this tech. But
well,
yeah,
I mean, that is the thing, right? If you spend 4, 5, 6 years designing and building a microcontroller, you really want people to use it afterwards, right?
Yeah, for sure. I mean, again, I really want to get on to talking about the RP2040 at some point, but since we're here anyway, this is a question I've come across a few times, is when it comes to sort of documenting something, because you write documentation as a living. I think a lot of people write it as a hobby. Most small projects are kind of one-person things, and really the documentation side of it is just their labor of love. So like you say, you want people to use your thing. But as someone who is, I suppose a professional person for documenting stuff, is there a point where you have to sort of draw the line and say, okay, this is the documentation side of it, and this is, from here on, is tutorializing, and it isn't necessarily my job to go too far down that path? So,
first of all, I'll say that I don't regard myself as an expert in anything anymore. I mean, I think from my bio, you can see that I have drifted across subjects. The only thing my doctorate is in physics, so it's like that's theoretically something I am an expert in. But my doctorate was a very long time ago now. My physics knowledge is 15, 20 years out of date, so I don't consider myself an expert there anymore. Yeah. I've forgotten most of the math I ever knew. So I very much view myself as someone that sits between disciplines and tries to make people talk to each other. And I think that's where documentation comes in. It's where tutorials come in.
Yeah.
And you've sort of drawn a line between documentation and tutorials there that I don't really think exists.
I'm so glad you said that.
I very much think that tutorials are a vital part of good documentation. Yeah. I think that I'm very much a teach by doing sort of person. API level documentation for software, like register level documentation for hardware and for ASIC is vitally important. It has to be there, because when you really need to know something, you have to deep dive into that. But what 90% of the people doing, like doing things with your hardware or your software, is they want to know how to get started.
Yeah.
Because once you get started, once you get over that initial friction of, oh, this is a new thing, I don't know how it works, I don't know how to get started, I don't understand the concepts involved. Once you get over that initial bump, then the API level documentation, the register documentation makes much more sense.
Absolutely. And yeah, and I'm so glad you said that, because it was a slightly cheekily loaded question, because I am someone who has learned to read documentation through tutorials. That's where all of my knowledge came from. It was never how does an ADC work? How does pulse width modulation work? No, it's how do you make a light dependent resistor make a LED fade? And yeah. I mean, I'm very much in the same place. I mean, my formal electronics knowledge was undergraduate courses in the let's say that was a few years ago, and the state of the art has moved on since then. And it was mostly around analog electronics, which is what they were teaching formally at the time. Yeah. So I'm very much a self-taught in electronics. I have a basic knowledge of ASIC design now after working with the RP2040 folks at Raspberry Pi. But that's far more than I knew a couple of years ago. And even in software, it's like when I started programming, Fortran was state of the art. Most of the code, where I learned to code was Fortran 60. It wasn't even Fortran 77. So I have a lot of formal holes. It's like if I'm talking to an actual computer scientist, I always feel my imposter syndrome kicks in very, very hard, right? Yeah. Because it's like, well, they know all these algorithm things that I don't really know. It's like, oh heavens. But for most people, even the people that have the formal training, when they meet a new thing, they need the narrative, because as human beings, this is true for everyone. As human beings, there's this huge wall when we meet a new thing. People don't like change. Okay? And people do not like change, and they don't like picking up new things, because they have to fit the new thing into their current mindset and into their base of knowledge. They have to expand what they know. Perhaps they have to change. Maybe something they know is wrong, which is hard to acknowledge, especially if your career is built around knowing things. Which all engineers and people involved in this sort of work is, that your career is built around knowing things. It's for a long time, when I was working as a technology journalist, my career basically depended on me knowing things before other people knew them, right? Yeah. And not only that, me knowing how that affected other things. So when someone said, hey, did you hear about this? And I hadn't heard about that, my stomach started to drop. And it was just like this feeling of like, oh no, what is that? I know that feeling so well. My brief time as an actual news journalist, when I had to get stuff out quickly, was miserable for that reason. It was just every day I'd get up and look at Feedly, and if I hadn't got there within an hour, I'd be like, oh no. Yep.
The thing about being blindsided as a journalist is absolutely awful. It's just like you feel that suddenly this thing is out there and it's like being reported on, and people are talking about it, and you don't know what it is. And your entire job is knowing what these things are before other people know about these things are, so you can tell them about them. Instant expert syndrome is a thing that applies to all journalists. Yeah.
Yeah, just again, talking as I did before about tutorials, I feel like that's a thing as well. The imposter syndrome in people who write tutorials, be that for things like embedded hardware or even just device tutorials, because there's a lot of people out there making good money writing user guides for things that shouldn't need them, consumer goods, for example, because there are things that are released that are somewhat impenetrable. But throughout the entire time I've been writing tutorials like that, I do it a little less these days. There was always this idea that all someone would have to do is ask a particularly pointed question about one aspect of the tutorial, and it would all fall apart for me.
Yes, the curtain would go away, and you would look behind the curtain, and the Wizard of Oz would be exposed as this this guy.
He's just this guy. But it's funny, you talk kind of talking about the whole idea of narrative, because it sounds very similar in a way. The way that there has to be a narrative to make people understand it. It's very similar to sort of the way narrative itself is taught. Because I know a couple of very good teachers who are linguistics teachers and storytelling teachers, and a completely different world really in a way. But one of their main things about kind of how to show something is that you can tell people about Joseph Campbell's monomyth and about the hero and all this kind of stuff, and you can lecture them for weeks, or you can just show them Star Wars once and say, Luke, that's the thing, and then you can apply that to anything and say, who's Luke Skywalker in this? And it's a far more effective way of teaching the monomyth than going through a very old and crusty text by Joseph Campbell,
Yeah, I mean, Harry Potter is Star Wars with lousy lightsabers, right?
Yeah, provincial UK Star Wars.
Pretty much.
So, I mean, one of the things that we should probably talk about, just as it is a relatively recent thing, maybe if we start at the Pico W and we can work backwards, because I do want to talk about the RP2040. But as someone who's instrumental for getting the documentation for the Pico W ready, how do you feel like the recent launch went?
Well, I mean, there's no other word I can use other than great. I think it went great. There is a lot of love for what we did around Pico W, and I think it's been obvious for the entire time that Pico has been on the market and RP2040 has been in the market that we were obviously going to add wireless to it. I mean, I think a lot of people were hoping that we would ship a piece of ASIC with wireless on board. I think those people have to realize how long it takes to design a piece of ASIC.
Yeah.
Designing a chip is not a trivial matter.
Mm-hmm.
So yeah, I think that the solution we came to was really great, and the fact it's exactly the same as the Pico form factor. You can just drop it into any of your Pico projects and your products, and now you have a wireless capable device. That's great.
Yeah.
I mean, from a personal point of view, it was a pretty scary launch. There was a lot of moving parts on this one. There was a lot of new documentation. There was changes to old documentation. We were very much locked into the date because, of course, Magpie, the official magazine of Raspberry Pi from Pi Press, had the existence of Raspberry Pi Pico W on the cover.
Yeah.
Like we didn't put it on the cover like we did for Raspberry Pi Pico, but there was a big picture of it, and most of the magazine was talking about it.
Yeah, exactly. Yeah.
So that was pretty scary. We couldn't at the last minute go, oh, something's wrong, we haven't finished this, we can't launch. Because anyone that knows anything about the magazine business knows that cover was set in stone a month ago.
Oh, it's done.
Like a month, maybe more. Like all the flat plan for that magazine was done a very long time before it went onto newsstands. The publishing industry has an incredibly long lead time for those people that haven't been involved. Sort of books are set in stone 6 months before you would see it on the shelves. Magazines, a couple of months. So the magazine you're reading, this month's magazine, is usually written 2 months before you see it.
Yeah.
So having everything ready to go at launch time was always a very scary story. And there was a lot of moving parts. There was schematics, there was data sheets, there was like getting started guides, there was changes to the existing documentation. All of that had to get ready, and I was sitting there at about 7:30 in the morning, like with about 20 windows open on my screen with the commands I needed to make all of these things go live on the internet ready, and I was typing them. Because you can't automate this, right? Because you don't want to automate this because it's too scary if it all goes...
It's too important. Yeah.
It's too important. You can't automate it. And I had my network connection, I had my backup network connection. And like there were 2 or 3 other peoples at Raspberry Pi that had the same. All of the bigger launches are like that, right? You have people sitting there running terminals. And of course, we're all working from home right now. Still, most of us at least. So going into the office isn't necessarily a thing, and it's much easier if you can just shout over to the person that has the access keys to whatever content management system that's breaking and go, hey, please fix this.
Yeah.
And there's still a couple of things that need doing around Pico, and I'm slowly working through those. But yeah, it went well. For from twisting your question into did all of the things happen that should happen? All of the things happen that should happen, and that's good. From a different perspective, which is probably what you were asking, was like, did people like the thing? They liked the thing. Everyone seems to have liked the thing. I was really happy.
If you are enjoying the Electromaker podcast, there are a couple of things that you can do to help us. The first is have a look at your podcast providing app or thing and seeing if it has a rating system. A 5-star rating with maybe a little note saying how much you enjoy the show goes a long way. It means that it's far more likely it will be recommended to other people who frequently look up sort of tech embedded related podcasts. However, the far more direct way you can support this podcast is by buying stuff at the Electromaker store. At Electromaker.io, we have a shop filled with all kinds of things from people like Raspberry Pi and Arduino, Pimoroni, Sparkfun, Adafruit. We also have a bunch of stuff at the more professional end of the spectrum as well, if you're looking for something to actually use in production rather than kind of hobby sides of things. We are not immune to the chip shortage, but we have a fairly decent stock of lots of things. While you're on the Electromaker website as well, it might be worth taking a quick look at the community projects page, because they are projects from the Electromaker community, 3 of which get rewarded each month for their ingenuity by a panel of judges. And we also have a quite amazing contest going on right now for PCB design, where you can get a €500 PCB fabricated for free and then use that in a project that will be entered into a contest that could then win you a further €1,000, which is kind of wild. That's with Euro Circuits, who are a PCB fabrication company right here in Europe. It's kind of an amazing thing. Anyway, yes, Electromaker.io has a shop, but this is the Electromaker podcast, and let's get back to speaking to Alasdair. I just hit my microphone. No, it's good though. I mean, because I was really interested in both. If you hadn't said both, I probably would have asked you next, kind of from the other perspective, because I think that is something that a lot of people wonder. Because especially with Raspberry Pi, in my mind, Raspberry Pi is unique. There's only 2 I can think of really names that have the same level. In fact, no, I'd say probably Arduino doesn't even have the same level. Raspberry Pi is unique in that when you release a piece of hardware, I don't think there's any other company that gets looked at the same way as you, because you have engineers right at the bleeding edge who are very interested in what Raspberry Pi are doing, right down to school kids who are learning to program for the very first time, who see Raspberry Pi as a very interesting potential idea, who have no interest in the other end of the scale. And then everyone in between, they're all online and they all have opinions. And so, I mean, that's one of the things, actually. There's always going to be a few people that have those kind of like weirdly dissenting voices, and as soon as something comes out. There was one thing that I wanted to... in fact, this is interesting. When I went back to look at this, I realized it was you that left the comment, which makes this even better. There were a few people that were falsely complaining that Bluetooth has been locked out of the Pico W, which doesn't make any sense. But I just wanted to sort of give you the... I know that you actually commented this on the blog post. But yeah, the Infineon chip that is connected to the RP2040 via SPI is connected via SPI. So if Bluetooth is going to appear on the Pico W, that is a software change rather than a hardware revision, right? Yes,
it is. Yeah. So the Infineon chip has... I can't even remember what the interface is. There's some Bluetooth pins on the Infineon chip which are tied off and not connected to anything. Mm-hmm. However, because of our driver, we can drive Bluetooth via SPI. Mm-hmm. So there's folks working on that now. I'm not promising any timeline. I'm not promising when it'll arrive. It is being worked on. So it should be a software change. There are no hardware problems with the board. Mm-hmm. When we enable Bluetooth, the hardware that's out there will have Bluetooth.
Yeah, and I mean, as I mentioned, having seen that initial comment, not realizing it was you at the time, because it was something I was going to mention to you, but when I went back to it, I kind of thought, okay, I can probably just say it and let you confirm it, given that it was literally you that wrote the comment. Because this always happens. You put out a board with a micro USB connector on it, and people complain it's not USB-C without realizing they're going to pay more to have USB-C on there.
Yeah, I mean, I couldn't say exactly how much they would add to the BOM cost or the final retail price, but it would be more. We would not have the same price point if we had put a USB-C connector on that board. And we had this last year. Was it last year for Raspberry Pi Pico? Pico was 21, right? 21. Yeah, I remember.
Yeah, start 21, I think, January.
Yeah, definitely. It was January 21. So we had this, and people said, it would not be a $4 board if we used a USB-C connector.
Yeah.
which is fine. There are plenty of boards with RP2040s on them that have USB-C connectors. And if you want a USB-C connector with an RP2040, you can go out to Adafruit or Sparkfun or Pimoroni.
Yeah, precisely. Yeah.
Or other manufacturers and get that. And you can get ones, or Arduino, like I believe the Arduino Nano RP2040 has an USB-C USB-C connector. It might do. I can't remember.
I should be able to tell you. There's one right there, but it's just out of reach with my current setup. So I'm not going to. I'm hiding madness in front of me. There's a collection of things that will avalanche.
Yeah, mine's over across on the other side of the room, so I'm not going to go up and get it. But yeah, there are boards with a USB-C connector, and if you want that, you can go out and buy them, and they are more expensive. There are RP2040 based boards that have a great number of sensors on them. The Arduino board, for instance, has a huge number of sensors, and it's correspondingly more expensive, and that's fine, right? It's aimed at a different niche. It's aimed at a different group of people. The Pico is very much aimed at a group of people that want a high. Well, it's not a high end. It's like a dual core Cortex M0, but it's like it's a very weirdly designed off axis Cortex M0 Plus. But it's $4.
Yeah,
and then Pico W is $6. And that is a specific niche, and we very much targeted that niche. Like Raspberry Pi is about producing not cheap computers. Like that cheap has a connotation that I don't really want to associate. We are reasonably priced. We try and hit, that $25, $35 price point on the main board, and we always want to maintain that for the main board. And for Pico, our price point was, accessible. Yeah. It needs to be accessible. It needs to be very cheap. I remember my editor at O'Reilly, Brian Jepson, at the time when ESP8266 was just released. It had just been released, and you could buy boards on AliExpress, like the tiny little ESP1 boards, which have like 4 pins attached, and were like this essentially. I don't even know what they were originally intended for. They were not intended for the thing that the maker community used them for, obviously, because the maker community reverse engineered that chip and built and made it the thing that it is. Yeah. But I remember Brian Jepson said to me, "Oh, that's cheap. That's fire it out of a cannon cheap." Yeah. And that's what it was. It's like it enabled a new generation of projects. It enabled projects that couldn't be done before, which are projects that needed cheap enough compute that it could be thrown away. Yeah. Yeah. And that's essentially what Pico is aimed at. Right? The Raspberry Pi Pico is cheap enough that you could essentially put it in a project and throw it away. Like it could be a disposable project. You could fire that project out of a cannon and not be entirely unhappy that you've done so. I mean, the military would have, $20, $30, $100,000 shells, smart shells or missiles that they fire. And for a military perspective, that's cheap enough it can be thrown away. Yeah. But for us, a $4 board is more on those lines.
For sure, yeah, and I mean, even the disposability of it aside, when you do think about the kind of things that are available for people, it's funny that you mentioned that, because I just out the corner of my eye noticed when you were talking about that, I have a Wemos D1 here, which is very similar, slightly more modern, but again, I think I got a bag of 10 of these for less than a tenner or something like that. But there's a difference between getting stuff straight from manufacturer from AliExpress and then being able to get a Pi Pico development board for $6. I think a lot of people don't necessarily understand quite the level of achievement that is.
Yeah, I mean, a lot of things. If you go to the main board, there's a lot of things that are billed as Raspberry Pi killers, and I've been working for Raspberry Pi for about 2.5 years now. So, and I spent a lot of time as a journalist before that, and like, there were people were always emailing me, and I still get emails today because like I'm still in the journals, the relevant email list for journalists, the press lists, about, hey, this is the new Raspberry Pi killer, and like. The thing that you went to as a technology journalist is, does it have any documentation? Can I actually boot Linux on this? I think there was a Jeff Geerling video that recently, maybe a month or two back, where he had a bunch of Compute Module 4 competitors. Yeah. And Jeff Geerling couldn't get Linux to boot on, I think, all of them. I think all of these competitive boards that were built as Raspberry Pi killers. It's like they had better specifications, but someone like Jeff couldn't get them to work. Like they couldn't even get them to boot.
And so they're not aimed at anyone except someone that could practically spin up their own board.
Yeah,
by that
so
point
essentially
anyway,
to get those to work, you would need to talk to the manufacturer directly. So you need to buy 1 million of them.
Yeah.
Or like 100,000 at least to get any interest in getting you in touch with the original engineers. And here we go back to documentation again, right? It's like everything can be made to work if you get to talk to the person that built it. And the job of documentation is to extract the knowledge out of their head and put it down on paper and in electrons so that people that are not them can do the thing. It's always the joke about Docker, right? It's this like Docker was invented so we could ship their machine.
Yeah.
Right? It's like that. It's the class, and I've said this myself, right? Well, it works on my machine.
Yeah.
And Docker is like, okay, then we'll ship your machine.
Yeah.
And it's like we've worked with folks from Docker, and it's like I have great respect for that. And it's like virtual machines have changed how we develop software. Because modern software is layers and layers of dependencies, and it's hard. It's really hard. I mean, especially when you get to high level languages to do that. So virtual machines have changed it, but in my heart of hearts, as an old fogey who was there at the start of a lot of these things, it always feels like cheating to me. You should be able to install software and get it to work on your machine, not their machine.
Yeah, but Docker is fascinating for that reason. And again, it goes back to that thing you were talking about before about narrative and tutorials and stuff. Because the idea of Docker was great, and the concept of Docker made sense to me. But it wasn't until I used Docker to create a Minecraft server that I was like, okay, that now it 100% clicks. Like every aspect of it kind of fit together.
It vastly simplifies things because it's a clean room, right? You're building things in a clean room where you have very static starting conditions, and obviously that's going to work better. And so the magic around Docker and around like the other virtual machine type stuff is to get that working in a way where it's a deployable thing rather than just like a machine. And there's whole levels of modern technology like that. It's like, layers and layers of technology. But documentation is about bridging the gap between it works on my machine and it works on your machine. And that's an important bridge, right? It's I mean, this is what human beings have used books for since we invented books. It's like it's what we've used cave paintings for, right? This is what like the cave paintings were intended to do. It was Absolutely. Like there are woolly mammoths over there. Use these pointy sticks to hit the woolly mammoths, and then we get meat and we eat tonight. Oh yes, and this is what fire is. That was documentation. Yeah. And it had narrative, right?
Yeah, absolutely. Yeah. I love that, actually. I'm going to have to, next time I'm fighting with any kind of documentation, I'm going to have to use that, which is this is the cave painting for how this piece of hardware works.
Yeah, I mean, humans are narrative. We're story-driven creatures. I mean, the phrase I hate to hear the most is the code is the documentation. The code is not the documentation. The code is the code. And sure, there are a bunch of people that can go in and they can read the code, and to them in their head, because they have pre-existing structures in their head that they can fit this piece of code in, that piece of code, this structure into, to them it is the documentation. They can read the code, they can understand what it's doing, and it all fine. Most people can't do that. Even people with like a lot of the same structures in their head can't do that because they're coming from slightly different code base. They're coming from a slightly different background, or a different language even. I mean, it's like how many computing languages can you write in? I think I'm up to about 13 or 14 different languages now. I don't have a favorite language. I have the language I will pick to do this task because it's the most appropriate language. Yeah. And you have to you have to get out of the mindset that there is one tool to do anything. And that's why I don't regard myself as an expert anymore, because you can't be an expert and be able to do that really. Because experts are there to be really good at one thing. And they are absolutely critically important. And I have greatest respect for anyone that can do that and not get bored.
Yeah.
I got bored,
Yeah.
and that's why I'm not a physicist anymore.
Mm.
But yeah, you need generalists. You need people to take that know enough about a subject to take the works on my machine and and write something and write some code and tutorials that let other people use the thing that those experts have built.
Absolutely, yeah.
Because we're specialized. It's the modern society is extremely specialized. Everyone is like in a vertical, and like you can only use those people in the verticals to build individual things. But you need generalists as well, because you need generalists so that other people in a slightly different vertical can get enough out of your vertical so that they can build their thing.
Yeah. Yeah, absolutely. Yeah, people have got to build beautiful things, but if people aren't building the bridges between them, no one's ever going to see them. Yeah, for sure. I mean, you mentioned you touched briefly on the idea of code being code, and that's definitely what it is. And another thing that I know you've mentioned is this concept of documentation as code, and it's something that I've actually been familiar with for a while. But for those listening that may not have ever come across this idea of documentation as code before, do you want to kind of briefly explain what it is, and then the way that you are trying to implement it with Raspberry Pi?
So sure. So documentation as code is a philosophy. It's using the modern software development tools to write documentation. So you should write documentation using the same tools as you write code. You should use issue trackers. You should use version control. You should use some sort of plain text markup so you can actually version control things. So Markdown, restructured text, ASCII doc. You need code reviews. You need to review your documentation. Copy edit is a thing. No one should write documentation and not have it copy edited. Mm-hmm. But there should also be automated tests. You should be able to build the final products. So that means that the documentation teams should follow the same workflows as software development teams. Mm-hmm. And they should be integrated into the product team. I spent, when I was writing the documentation, or when I was pulling in the documentation from the ASIC group that designed RP2040, for instance, I was essentially embedded into that team. I turned up at their meetings. I did things with them. I worked in the same issue. The documentation tickets were in the same issue tracker as problems with the ASIC itself. Mm-hmm. So you have to be integrated. You have to use the same tools as programmers. So in Raspberry Pi, when I was brought in, a little bit of history here, I guess. I was brought in by Eben just at the start of the pandemic. So I started at Raspberry Pi in February 2020. And for those that aren't in the UK, we went into lockdown essentially maybe 2 weeks later. So our first big lockdown. So that was interesting.
Yeah.
But essentially I was brought on to make sure that there was accessible documentation for RP2040. RP2040 is the first piece of custom ASIC designed by Raspberry Pi in-house. So we have the team that designed it. We're responsible for buying the wafers, like getting it through production, like getting everything, getting it packaged, and all the logistics about taking it from grains of sand that we've tricked into thinking all the way through to a piece of silicon you can solder onto a PCB.
Yep.
But to do that, to use that chip, you need, I think the datasheet for RP2040 is about 850 pages long. Mm-hmm. I mean, to document a piece of silicon at the register level is not a trivial task. And as I think I've said previously, it takes the people that built that to do it. Mm-hmm. It's like I've had a lot of credit for the documentation around that, and I'm very grateful people like it, and we found it useful and think it's good. But I sure didn't write that. Like, that's impossible. No one person could do it. It's a team effort. It's like that. You can't write. Even one person in the ASIC team couldn't sit down and write that whole thing, because building a piece of modern silicon, even something like RP2040, which is a 40 nanometer process, which is is a relatively older process, is not something that could be done by a single person anymore, I don't think. So documentation as code is trying to integrate the documentation into the build process, into the development process of a piece of software or a piece of hardware. So I came on board a couple of months before tape out. So most of the design process had been done. We were in the lead up to actually taping out the first pieces of silicon.
Yeah.
And then there's about a year between tape out and getting volume production and getting enough pieces of silicon and boards ready where we could actually release it as a product. And that year was essentially spent writing the documentation. So if you go and read the RP2040 datasheet, or getting started with Raspberry Pi Pico, or hardware design with Raspberry Pi, with the hardware design with RP2040, any of those books that were written during that year.
Right, yeah.
And some of it is mine. I wrote quite a bit of the getting started guides around the tutorials level documentation, because that's the level I understood it, and that's a necessary thing, right? You have to have, not only do you have to have that, you have to have someone condensing down like the data sheets and all of those things down into a level of like, well, how does someone that isn't you and hasn't spent the last 4 years, with FPGAs in front of them do this?
Yeah.
How do you get started, really? And that very much was written in parallel as the CSDK evolved, for instance. And then there's like, the revisions and that went in parallel. And it's like every time there was an SDK change, I had to slightly change the getting started documentation. So documentation about and code is very much integrating people writing documentation into the people writing the software and people designing the hardware. Because when it comes down to it, it is another build product. So if we actually have a whole tool chain, it's all our documentation is written in AsciiDoc, which for those not familiar with AsciiDoc, it actually comes out of the DocBook era, which was an XML markup language, which theoretically people tried to write by hand, like human written XML. It was awful. I tried to write a book in it, and I stopped and didn't, and told, I think it was O'Reilly was my publisher at the time, told them I wasn't going to do that. And they went, hey, there's this new thing called AsciiDoc, you should write in that. And it was like, it's much easier. It's essentially markup. So if you come across Markdown, which I think most programmers will have come across, AsciiDoc is like Markdown, and there are actually some similarities, and you can almost compile Markdown as AsciiDoc, except there are things that won't compile and will break, and so it's actually quite hard. When I've been writing Markdown, I have to switch into AsciiDoc, and like I have to drop like a whole language out of my head and load in the next one. It's like switching between some Objective-C and C, or has C# or a closely related language family. So all of our documentation is written in AsciiDoc, and then we have a Ruby-based toolchain with some Python and a few other sort of in-house stuff to take this and turn it into PDF. So this is where what I regard as the PDF documentation toolchain. It's like, so the data sheets and the getting started guides associated with Raspberry Pi Pico and RP2040 are all written in AsciiDoc originally. On the flip side to this, I've actually taken, when I came in and started working for Raspberry Pi, the online documentation for the big boards, like the mainline boards, are Raspberry Pi 4, Raspberry Pi 3, the compute modules, was all written in Markdown. And there was a Python script which ran every hour and generated some web pages from that. So that was all in GitHub. So it was actually revision controlled Markdown, which was pretty good. But it was very much the structure of the documentation hadn't scaled well, at least from my point of view. It's very much a tree-like structure. It was a web page. You clicked and clicked and clicked and clicked and clicked and clicked, and you clicked down and down and down until you got to like 2 paragraphs that actually mattered, and it wasn't in context. There was no narrative. It wasn't in context with the surrounding documentation. So one of the big job that I did immediately after Raspberry Pi Pico launched and all that PDF documentation was available, was taking, along with people working on the tool chain. This wasn't just me. There's a bunch of people that work on this at Pi, and we have some really good contractors that we bring in. We took this Markdown, and we took it out and we built out fire and forget toolchain. This is Andrew Scheller, who works with me, who built a fire and forget toolchain that essentially took the markdown, up converted it, and then down converted it into ASCII doc, and then that was working. And then you built HTML out of the ASCII doc at the other end. So it was like taking the markdown, and there were people still actively committing to the markdown repo at this point, because we have a bunch of contributors to the online documentation that didn't know about any of this, because we were doing it all in private, like behind the scenes, and we were tinkering, getting this working. And so it's like it pulled in this the real live documentation repo as a submodule into the toolchain repo that translated an ASCII doc, and then fired it off as HTML, and built the new website that pulled all these markdown files together, created ASCII doc documents. And then at one point, I got Andrew to do it because he had written this, because it self-deleted a huge amount of code. Yeah. And it's like, if anyone was going to delete his code, it should have been him. Yeah. And I got him to push the go button because he deserved it. And what this did was take the markdown in for the final time, import it, turn it into ASCII doc, and then the source of truth, because there should always be one source of truth. I haven't talked about source of truth at all. And if you are writing documentation in the same way, and this is documentation is code, in the same way as code, there should always be one source of truth. There should always be one source of truth. Yeah. And until that point, the markdown was the source of truth. And then suddenly when we typed this, and we, there was the yes, are you sure? Yes, are you really sure? Yes, are you really, really sure? Like, I think there was 3 or 4 prompts to make sure that you couldn't run this sort of command line argument accidentally. Yeah. The source of truth was now ASCII doc. Mm-hmm. And on that day, we flipped that repo into the main repo, and suddenly all of the online documentation for Raspberry Pi changed, and it looked differently, and it was generated from the ASCII doc. Yeah. And I am still very much in the process of, because I took all of the markdown, which wasn't necessarily how I would structure the documentation. It was very much a legacy documentation set that goes into different depths and different topics, depending how interested people were in that particular topic. And good documentation has a voice. It has a single voice that speaks. It has a level, it is at the same level for everything. And that even today, the documentation around the main boards is not in a single voice. It's not at a steady level. It goes into very much more detail about some things than the others. And you can see that around... if you, for instance, you go to the documentation on the Sense Hat online, and then you look at the post-me documentation around something like the Build Hat, the level of documentation around that is very much different. And you'll see that the Build Hat documentation is very much a tutorial-based approach. It's very much code samples and tutorial and how to get it working, whereas the Sense Hat documentation is like, here's something, here's another thing, there's another thing, bye. Yeah. Which is fine, right? That's... you can get it working. It's fine. There's documentation there. If you want to get it working, you can do that. And it also speaks to the split between the foundation and the limited company, right? If you're looking for if you're looking at the educational resources around the Sense Hat, which was very much built as an educational resource in the beginning, that's all in the Raspberry Pi Foundation documentation stack. And for those that aren't aware, there's actually 2 entities. There's the Raspberry Pi Foundation, which is the educational charity that is dealing with, like learning resources and curriculum resources. And then there's Raspberry Pi Limited. And Raspberry Pi Limited is the company I work for. We build the hardware, we design the hardware, we document the hardware, we document the software, we make sure the software works in all the hardware, and then we build and sell you the things. And of course those have the documentation I write has a very different target audience to the documentation that the foundation is writing. And as it's progressed, the documentation of the foundation is much more focused around curriculums, it's much more focused around learning outcomes than the documentation you want to get started, because it's very much it's leading you by the hand to certain learning outcomes.
For sure, yeah.
Yeah. And that's absolutely intentional, and that's absolutely a necessary thing. So a lot of the documentation around Sense Hat, for instance, has been done by the foundation and is very much a curriculum learning outcome focused documentation, whereas the documentation that documentation also exists around Build Hat, because that's another thing that the foundation were very much involved in. For those that don't know, the build hat is the Lego build hat. It's you can get your Lego talking to Raspberry Pis, which is pretty cool. It's if you haven't come across it, go see it. It's quite fun. There's like some really nice builds people have done with it.
It's one of those things that with the build hat, every now and again there are those things that hit me really hard where I think if my kids were just a little older, we would be all over this immediately, because it's exactly the kind of, it's exactly the kind of thing that had it existed when I was a little bit younger, I probably would have learned programming from my dad like I was probably supposed to.
Well, yeah, I mean, so my eldest is 13, and honestly, he's right in the trough for this, and he's, it's what dad does. It's like, I don't want to know about that. So yeah, it doesn't necessarily. It's sometimes yes, sometimes no. It doesn't always go that way.
For sure. I mean, I feel like there's a lot of things we touched on today that I could ask you a lot more about. So I mean, I don't know if at some point in the future you'd be happy to come on again and chat about more Raspberry Pi stuff, but also I'd be very interested to hear about some of the other Physics Days things. But for today, before we finish, there's one question which I also sprang on Eben actually, and I think this is going to have to be my finishing question for when I speak to people, because it's one of my favorite ones to ask people. So in my case, I have a bunch of SEM 3340 chips on my desk over there, which are going to go into the tabletop synthesizer that I will build when I have the time. What's the one big project you've got kind of somewhere in your mind, but you just do not have the time to even begin to attempt right now? But you're going to do it, for sure.
So I actually have 3 of those. Okay. So the first one is something I've actually built on a much smaller scale for an NDA'd. So I can't talk about who it was for, but I can talk about the project. And there's no documentation for this online anywhere, because that I am not allowed to publish. And that was literally firing the things out of a cannon because they were so cheap. So I built... if you look really hard on my Twitter, you'll find some ESP8266 boards stuck with Adafruit wireless charger inside ping pong balls with RGB LEDs and accelerometers. And it was just like the first initial stages before someone gave me a bunch of money to build it for them. And this was back in my freelance days. So essentially it's the cool thing about this is you can basically build an air cannon, fill it with ping pong balls, put a sabot thing on the top so that like you actually maintain pressure, and fire them out of the cannon. And because you can build mesh networking into that, because you can do Wi-Fi mesh, and you can essentially build this amazing visualization of how things spread out, and you can actually do some interesting design work around that. But also it looks really cool because you do it at night, so you get the flashing LEDs, and it's just like, oh wow, it's just great. So there's I have some amazing data sets of like firing like 100 ESP8266 connected boards out of an air cannon. I would love to do that again, but with a much, much bigger cannon. And obviously using RP2040 now, right? Because it's just a better. I can do more things with it. So that would be a great thing to do. The other one of the other projects I want to do is the personal time zone clock. And this brings together, this is something I used to travel, pre-pandemic, I used to travel a lot. I used to do 150,000 flight miles a year. Because one of the things I did for a living was I spoke at big conferences. Remember big conferences? Like 10,000 people in the same room? They were weird. I was like, it's hard to imagine now. But so one of the things in the playroom where my kids are, there's actually like a row of clocks, like like London time, New York time, San Francisco time. Like the things you used to find in 1960s offices where they had their teletext and like phones, and just to figure out when they could phone people. And what I wanted to desperately to do to have one of those have daddy time. So essentially what it would be a microcontroller on the back of a clock that sat on a Wi-Fi network that moved the hands, could move the hands independently. And so there would be an app running on my phone, and every time my phone changed time zone, it would change the clock hands.
Yeah, that's a lovely idea.
and I've never gotten around to building it, and I desperately want to do it. And it was something I pitched as a product for several manufacturers at the time, and no one ever wanted to pay me to do it, which was really disappointing.
It's funny you mentioned that, actually. One of the projects that I never got round to finishing, but is not dissimilar, when Harry Potter fever was at its sort of second height, I guess around the time the last film came out or something like that. One of the things that I had like a working prototype of pretty much was a Weasley clock.
Ah, yes.
The idea being that it was, I mean, horrific from a privacy point of view, but you use the GPS tracking on everyone in the family, and then cross-reference that with how long it roughly takes them to get home from a specific point.
It's entirely doable, right? Like, sufficiently advanced technology is indistinguishable from magic.
Yeah.
And because it really is, it's like you can do it with a iPhone app that has geofences around certain locations, and like you have the GPS tracking, and you move into those locations, and it sends a push notification up into the cloud, and the cloud that goes down into your thing, which is webhooked, and it moves the hand. It's like it's entirely doable. Yeah. It's like when I watched the movie, it was. I mean, the books came out, but I think I remember. Did the movies come out around the time? Was it 2005, 2006, 2007 when the first Harry Potter movies come out? Or am I totally retconning this?
I'm not sure. I remember because obviously the movies came out, I think, when the books were still being written, and I don't know. I remember being at the right age that I read the last Harry Potter book at a music festival.
Okay.
So exactly what that means, you can put two and two together.
I'm Googling this. So the first Harry Potter movie was 2001. So it's
right.
I'm totally have false memories of this, because I remember looking at the Weasley clock and going, "Ha! I could build that."
Yeah.
Which of course in 2001 was physically impossible, because that would absolutely totally rely on having the iPhone, and which was 2007.
Yeah.
So it's a total false memory syndrome of some point post 2007, when I had the iPhone toolchain and I was writing iPhone books at the time, going, "Oh, I could build that. I know that." So that was definitely totally retconned in my head. But yeah, you could. It's totally buildable.
It's crazy, isn't it? I love the idea that there's the phrase, any technology indistinguishable from magic. Sufficiently advanced is indistinguishable from magic.
Yep.
And it's sort of our job as makers these days to just continually prove that phrase true.
Yeah, I mean, the sufficiently advanced technology is technology that's invisible.
Yeah.
I mean, that's the real point. So this is like a whole different conversation, right? And it's like we obviously don't have time, but one of the things I get is technology is about friction.
Yeah.
If you build a product, you build a piece of technology, and the friction to use it, no matter what extra features it gives you, if the friction to use it to do the basic thing adds more friction than was there to beforehand in the dumb version, then no one will adopt it. And you see this in IoT in the home, for instance. It's like, how do you use a smart light bulb? Well, it's like you've got your phone and you walk into the room and you have to unlock your phone, and then you have to go to the app and you have to you have to click the right button in the app to turn your light bulb on or turn it red or whatever it is you want to do to it. How did you previously use the light bulb? Well, you turned it on and a switch on the wall. Yeah. Which you can do in the dark. And takes less time. Yeah. How do you break a smart light bulb? By turning it off on the switch in the wall that we've been trained our entire lives to use.
Exactly. Yeah.
Right. So it adds friction. It's like, what should be smart is the switch on the wall. But that's a huge amount of friction at installation. Yeah. Right. Because most of us, you and I could probably install a new light switch. Most people can't. Most people, and depending which country you're in, it's not necessarily legal for you to install a new light switch. Yeah. But if you you have to get an electrician into your house and you have to install a light switch, so you have to be really committed. So there's huge amounts of friction to install smart light switches. Installing smart light bulbs there's not a lot of friction at installation. You screw in a light bulb. Most of us can manage that.
Yeah, for sure.
But it adds friction every time you use it. So the thing about technology, the thing about sufficiently advanced technology is that it is invisible. It should be doing things for you, behind your back.
It's so funny. I know. I was starting to bring things to a close, but I can't really not talk about this, having said that, because you've just touched on something that I think is so important, and something that I if I ever make a thing in my life that I'm going to sort of release. Be it a nice open source project, something you can build yourself, or maybe even a product I sell. I don't know. But if I ever did make something, this idea of technology being invisible and there being very little friction towards using it. Again, coming back to synthesizers. I mean, music was my thing before anything else, and I got into microcontrollers partially because I thought it'd be fun, but also because I thought this seems like a good way of creating noises and bleeps and bloops. But the kind of art creating devices, be them synthesizers or be them pieces of software for drawing tablets or apps or whatever, the ones that I love are, I think it's called. There's two types of creativity. I may be misquoting this, but there's kind of type 1 creativity, which is where you are someone who is trained in the art that you're being creative in, and you have intention, and you know very distinctly what you want to make, and then you make it. And then there's type 2 creativity, where you just gesturally work in a way that feels right, and the tools you have facilitate making beautiful music or art.
Right. Yes.
Just yesterday, there's something I'm going to feature on the Electromaker show probably this week. There's a thing called the Abacus Synth, which is an abacus synthesizer. And all of the low-frequency oscillators and all of the sounds that it makes are on abacus lines with spinning discs with inertial measurement units in them. So you spin it, and the speed it spins is how fast the vibrato of the note is. And you instantly understand how that works. Huh. And I'll send a link through to you afterwards.
I definitely want to look at that. That's
at.
Fascinating. Doesn't use a Raspberry Pi, does it?
I have no idea. It'd be good if it does, though. That would be a bit of a coup, wouldn't it?
That's a good seg into the next topic.
Absolutely. But no, as I said, I really could talk to you about this stuff for a lot longer, and I would like to actually. If you're willing to chat to me again, maybe in a month or two's time, because I'm hoping to make this a little bit more of a regular thing. But for now, I'll let you get on. Just before we do drop off, I mean, obviously we've talked about quite a bit. Is there anything specific? I know Raspberry Pi does not talk at all about future things, but is there anything specific you would want to sort of mention before we head off?
No, I don't think so. I think I've pretty much hit the high points. I mean, go get a $6 Raspberry Pi Pico W, right, and go build something. I think is the call to arms. Absolutely, yeah. Agreed. Well, yeah, I mean, you can go and definitely go and buy one. And I suppose I should do my little bit as well. If you are a watcher of the Electromaker show, or you haven't been watching it thus far, we do actually give away a lot of hardware on the show, and we will be giving away a Pico W relatively soon. I say relatively soon because it means I'll have to give the one away that is sitting on my desk, and I'd like to play with it first. But yes, we will be doing that. I think I can probably find you some Pico Ws to give away.
Lovely. Well, that's nice to know, actually. I think at some point it would be nice to do a grand Pico giveaway of some kind. But for now, thank you so much for chatting to me, Alasdair. I'll be in touch at some point in the future about doing this again. But it's thanks so much for talking to me today.
Thanks for having me.
So that was Alasdair, and what a fun conversation that was, at least from my perspective. I hope you enjoyed it as well. Alasdair will definitely be coming back on the show. As you heard during the podcast, there were a few little avenues we didn't have the chance to go down, and it's just clear that he's someone who will be very interesting to talk about in general. The thing that he mentions in the podcast, perhaps, or maybe it was actually after the podcast was finished recording, he's just written a fantastic article in Stacy on IoT's newsletter about the perils of smart home tech and what needs to be changed in order to make it viable, really. And it's a fantastic read. I will leave a link to it in the podcast description. There are other guests who have already agreed to be on the show, which is really nice. It seems like this interview idea finally has some legs and will be sort of going somewhere. But for now, I will leave it at that. I will be back with a regular Electromaker Show podcast next time. And in the in-betweens, if you do want to get anything for your projects, do have a look at the Electromaker store. I've said it many times, and I know not everyone uses it, but the Discord server is a great place to contact me directly or to speak to other people who are into Electromaker. And if enough people sort of ping me and say, hey, I'm here just from the podcast, really, I'd be totally up for making a purely podcast-only channel. We could maybe even come up with some kind of listen-along idea, but obviously everyone listens to podcasts in their own time. That's a terrible idea, Ian. What are you talking about? Anyway, that is it for this week. Thank you so much for joining me. I hope you're having a safe, fun, and creative time, and I'll chat to you soon.